Evaluate the limit as x tends to 0 of e to the x sine x minus x over cosine 2x minus 1. So let's begin by sort of rewriting this guy so that we can go through the basic Pliers algorithm. We have e to the x times sine x minus x over cosine of 2x minus 1. Now the first step is to try plugging in. We would have e to the 0 times the sine of 0 minus 0 over cosine of 0 minus 1. The top simplifies to 0, the bottom simplifies to 0, so this is type A indeterminate, and that means we can hit it with the L'Hopital stick. So let's apply L'Hopital's rule. We'll have the same limit, the limit as x tends to 0, but we'll replace the top by the derivative of the top. So using the product rule here, we'll have the derivative of the first times the second, plus the first, e to the x, times the derivative of the second, cosine x, then minus the derivative of x, or minus 1. On the bottom, the derivative will be negative sine of 2x times the derivative of 2x, or 2, and the minus 1 contributes nothing. So let's clean this up a little bit here. This is the limit as x tends to 0 of e to the x times the sine of x plus e to the x times the cosine of x minus 1 up top, and down below we have negative 2 times the sine of 2x. And let's repeat the entire process. If we try plugging in x equals 0, we're going to have e to the 0 times the sine of 0 plus e to the 0 times the cosine of 0 minus 1 over negative 2 times the sine of 0. Cleaning up on the top, this is going to be 0 plus 1 minus 1, or 0 on top, 0 on the bottom, so it's still type A indeterminate, and so we're going to hit it with the L'Hopital stick one more time. This is going to take a little bit more effort. So we still have the limit as x tends to 0. We've got to replace the top by the derivative of the top, so leave there some space here. Doing the product rule on the first part in pink, we have x times the sine of x plus e to the x times the cosine of x, just like we had before. Working on the green bit, the derivative of the first is e to the x times cosine of x, plus the first bit, e to the x times the derivative of the second bit, negative sine of x, and then the derivative of the minus 1 bit at the very, very end is just going to be a 0. On the bottom, the derivative there will have negative 2 times the cosine of blank times the derivative of blank, so 2x and a 2. Notice that the e to the x sine x and the e to the negative sine x cancel, and so this can be simplified as the limit as x tends to 0 of, on the bottom we have negative 4 cosine of 2x. On the top we have 2 e to the x cosine x's. And so we can cancel the 2 into the 4 and have the brand new limit as x tends to 0 of e to the x over cosine of x, with a negative out in front, and 2 cosine of 2x in the denominator. If we try plugging in x equals 0, we get e to the 0 times cosine of 0, negative, over 2 times the cosine of 0. That simplifies to a negative 1 over 2, and since that's a real number, that's our limiting value, and we have the limit.